Good afternoon, everyone. I'm Debbie Ingalls. I'm the director of the Cool Climate Enology and Viticulture Institute here at Brock, and it's my pleasure to introduce our speaker today for our ongoing CCOVI Lecture Series. So this afternoon, I'm pleased to introduce Dr. Jim Willwerth, who is one of our viticulturists here in the Institute. Jim earned his undergraduate degree at St. Mary's in Nova Scotia, and then completed his PhD here at Brock University under the guidance of his supervisor, Dr. Randy Reynolds. He's front row here today. So at the Institute, he performs research and outreach services in the field of viticulture with an emphasis on grapevine winter hardiness and the overall priorities of the Canadian grape and wine industry. His current research interests include grapevine cold hardiness, freeze protection, and clone rootstock evaluations under our Canadian climate conditions. And I think probably this afternoon it's very timely for this talk because we're calling for a big snowstorm to come in, and who knows what Mother Nature is going to throw at us anymore from year to year. So with that, Jim, I'll hand it over to you for listening to your lecture this afternoon.
Thank you very much, Debbie. Thank you very much, everyone, for being here today, and everyone viewing online. This is my 9th year now, I think, speaking at the CCOVI Lecture Series, so I'm trying to mix it up a little bit and talk about actually some of our long-term research that we have ongoing with some of our industry partners and stakeholders. And the idea of evaluating plant material has always been an interest of mine. I mean, I worked with Andy Reynolds and Helen Fisher, and when you work with individuals like that as a student, you definitely get an appreciation of different material being used worldwide and how that material can really help adapt to climatic situations. And right now we're in a period of unknown for our future climate. Every day you hear in the news about climate change and what's that impact. Not only it's going to have huge impacts on our social and economic aspects of our lives, obviously our health, but it's going to impact agriculture and how we're going to be fed and eating and so on. So this is what I want to kind of talk about today. And you look back on the news in the last year, and if you know the Billy Joel song, "We Didn't Start the Fire," it talks about basically 40 years of events from, I think, the 40s to the 90s. And it's all these just one word, no real verses or anything like that. And it's kind of like, whoa, what were some of the climate-related events in wine regions alone in 2018 and even at the beginning of this year? We've got wildfires, extreme heat, extreme drought, cold, extreme precipitation. Talk to people growing grapes in the East Coast, in Virginia and places like that, and they said in 2018, the fall of 2018, we've never experienced a vintage like that in over 30 years. So we're finding a lot of these pressures in these extreme events happening worldwide. With that is also growing pressures on reducing chemicals in the field, and Europe especially has really put a lot of pressure on that. Look at honeybees and insecticides. There's a lot of pressure locally on reducing agrochemicals. With that also comes the cost of production. That's increasing. And again, many unknowns. And it's hard to make a long-term strategy against things when the politicians aren't agreeing with each other, and one group gets elected and they want to do one thing, and then the next group comes in and says, we don't believe in that, and we don't know what the future holds for long-term policies. So it's a really difficult situation. Now, in terms of some specific, and these are just small, I shouldn't say small, but just a couple of the impacts of climate change for agriculture. One is obviously climate change is associated with higher CO2 levels. With that as a single factor, it would improve production and yields. However, with climate change, we have these extremes in volatility in terms of temperature, precipitation, and with that comes a lot of other stresses on not only growing crops, but our lives. Wildfires, habitat loss, lack of water. When there's no water, it's hard for a plant to grow and for us to grow crops on a commercial scale. The other big problem has been pests. And with climate change, we could have a higher incidence of insects, disease, and so on. And one of the things that scares the daylights out of me is like pest movement into non-traditional areas. And in that bottom corner is the spotted lanternfly, which is a pest that's really moved up It's in Pennsylvania and parts of the East Coast, and that's probably going to move up to some of our production areas, and that could have devastating consequences. So, global travel and things like that in our global economies are good, but they do have some consequences, such as movement of pests and diseases, especially invasive ones. But it's not just warming when we talk about climate change. There's a lot of cooling instances that are going to be happening. We've experienced them in North America. And here's just a quote from a professor of atmospheric chemistry at Leeds. So as you can see, it's not just overall global warming, but we are finding that we can have some extreme cold events, such as these types of things with the polar vortex, which we're all familiar with from some of the past winters that we've had. We have an Alberta clipper coming in, so it probably hopefully won't stay around for too long, but these events can reach deep down into the southern U.S. and hurt crops like citrus and so on, but obviously impact us tremendously in Canada. So in terms of viticulture, every viticulture region will be impacted at some point by future climate. In the areas that are suffering the most or will suffer the most are probably areas that are already hot and dry. You see in the news in Australia how Adelaide and places like that, they have temperatures over 40 degrees, warmest they've had since they had one event like that in the 30s, and since then they've been getting warmer and warmer. What's also happening with the warming periods during the growing season is we're getting a shift in phenology, earlier bud break, bloom, veraison, shorter periods from flowering to harvest. So the fruit chemistry is starting to change in a lot of our traditional grape growing regions. And I highlighted two things that I'm going to talk about the most in the impacts of some of the work that we're doing here, is how temperature extremes, precipitation extremes, and that variability and erratic weather, particularly how it can impact dormancy and hardiness. That's some of the areas I want to focus on today. But in terms of viticulture, some specific issues. I mean, grapevines are perennial woody plants, so they have to overwinter. It takes many years to get them into production, and they're more difficult to grow per se compared to, let's say, an annual crop where you can switch out easier. They are susceptible to pests and disease, again, sensitive to frost and freeze injury. And one of the really interesting things about viticulture is the whole aspect of terroir and how regions have the distinct typicity and regional identity, and that is starting to change in many wine regions that are being impacted by climate change. The other problem with viticulture is in many regions it's monoculture. There's a lot of monoculture, and regions are built on specific varieties. I mean, if you think of Burgundy, for example, what do you think about two varieties, Pinot Noir and Chardonnay? And it's not just the growing season that will have the impact, but those environmental changes can impact physiology throughout the whole year, as well as the chemistry. So this will impact not only the production of the grapes, but all aspects of viticulture and enology. And I mean, one of the hot issues in enology have been high alcohol wines, because the fruit is getting higher and higher in sugar, and people are trying to get away from drinking higher alcohol wines. Winemakers are trying to limit how much alcohol are in the wines, but it's difficult when the seasons aren't allowing it. So that leads to adaptation. So agriculture adaptation to potential climate impacts are becoming more urgent. I think that's you see that with a lot of the extreme scenarios that we're dealing with, and with that also these are long-term strategies. They love and can't be fixed overnight. There are some potential adaptation strategies that are more short-term, more kind of band-aid effects, but the long-term ones are the most important. But unfortunately, if the impacts are very severe, that will really limit the effectiveness of any type of mitigation strategies. And like I mentioned earlier, when it comes to this integrated solution, there's a lot of barriers in terms of trying to find a real solution to our problem. And a lot of them are political and economic and social, because a lot of changes are going to change our way, or will change the way of our lives. So what are growers doing in Ontario, across Canada, and worldwide in terms of adapting to changes in climate, or just even within one growing season, different extremes, which we can have here in Canada for sure. Some things are training systems, canopy management are really big now in terms of ways to mitigate some of the climatic challenges. The picture on the right there is a leaf remover, mechanical leaf remover that's being used more and more in areas around the world. So cultural practices are changing, more irrigation is being used, regions are expanding, or new regions are starting to become established. And finally, plant material. Now, plant material has always been looked at. I mean, that's why we have so many cultivars and so on in viticulture. But this remains to be, the tried and true, the main way to deal with a lot of climate effects. And that includes selection of material, breeding material, and obviously evaluating material in different regions. So the selection of plant material is an important resource for adapting to climate. You can look at it from like the bigger picture in terms of different species or crossings of species. Then within, let's say Vitis vinifera, we have different cultivars. Within the cultivars, we have different clones. They're grafted to different rootstock, and then also quality of material. So all of these are areas where plant material can impact, or you can use plant material to improve quality or performance. So in terms of cultivars, they're not all equal. Grapevines are extremely diverse. There's over 60 species of Vitis, roughly 14,000 cultivars in vinifera, with thousands of synonyms. And there's probably a lot of confusion still because all the genetics haven't been done on all of these. And there's also a lot of intravarietal diversity. And with that, different clones and ecotypes within our major cultivars. So Sangiovese, for example, there could be there's some studies that have been done on 10 different, basically, ecotypes of Sangiovese, or you can look at Primitivo and Zinfandel, these really ancient varieties that have been grown in different parts worldwide or clones sourced from different areas. So that's an area that people are focusing on even right now. In terms of different cultivars, they all have different growing, they can have different growing season requirements, different tolerance to drought, obviously difference in terms of hardiness and how they acclimate, how they deacclimate, and so on, the rate of fruit maturation, their fruit chemistry, growth habits, and so on and so forth. Rootstocks, now they've been used in agriculture for many years. There's four main benefits of rootstocks. One is resistance, tolerance, growth, and uptake. So resistance to things like phylloxera, nematodes, and other pests. Tolerance to things like water stress or salinity. Growth in terms of either growth cycles or growth control. Some rootstock are more vigorous than others. Adaptation to different soil types, and so on and so forth. Clones are another one within a variety. There could be a number of different clones, especially some of our really common really common varieties or older varieties, or varieties that mutate a lot, like Pinot Noir. Clonal selection has been done to achieve earlier or later maturation, growth habit, color or flavor, cluster morphology, berry size, and that related to wine quality and so forth, or disease resistance. And one thing that we're looking at here, and hasn't been done a lot, has been looking at cold tolerance within varieties and within different clones. Finally, I just want to touch on quality material, because if we put material in the ground and it's not good, not of high quality, the performance is going to suffer. And so we want material that's a good source, good propagation techniques and so on, good grafting, good callousing, that type of thing. But we also want them to be true to type. So we want them to be true to that clone that we want to put into the ground in that variety. And finally, we want them clean from major viruses and diseases. So this has been a big initiative here in Canada, has been to have a domestic clean plant program and understand more about how these types of issues in terms of quality material can be mitigated, because this is not going to help you adapt to other stresses like extremes in temperatures and so on and so forth. So I wanted to touch on that. And we are doing some more work in this field and looking at how viruses do impact plant performance, including hardiness and so on and so forth. So all regions, or most regions, have been evaluating plant material for many generations. If you look at a lot of the varieties and clones selected, they go back many, many years. You know, we've been, as a species, we've been cultivating vines for centuries. So with that, obviously, we've been selecting material and evaluating it. But climate change is really driving traditional regions, I would say, to really put more and more emphasis on in terms of new varieties, crossings, and so on, because they're having a really difficult time and they feel that moving forward, these varieties may not perform well, and it could be a real challenge to them. These are regions like Bordeaux, Alsace, Burgundy, and places like France where you don't hear a lot about hybrids and that type of thing. But right now, there's a lot of focus on rootstocks and clones because they would like to keep those varieties that the market likes, and there's so much value in the product. So they are looking at more rootstock and clones. And like I said, even doing some varietal evaluations, what I just said is blasphemy for probably some winemakers would think that. But again, looking at new crossings, traditional varieties, indigenous varieties, going back to some heritage vineyards, and looking at some of these really old varieties. And so these are some of the things that are being done. Regionally here, we've been looking at Vitis vinifera mainly in recent years. Regional evaluations of existing and new material are important in not only Ontario, but BC, Quebec, Nova Scotia, but we all have different needs. BC, they're looking at some varieties, some non-traditional varieties even, down in the warmer parts of BC, the Portuguese varieties and those types of things. We're focusing a lot on the cool climate varieties, but that doesn't mean there's not some Italian varieties and some other ones other than your classic, Pinot, Chardonnay, Riesling, Cabernet Franc. One of the main traits that we're looking at right now is cold tolerance and also clean material. So I want to talk about some work that we've done over the years with our cold hardness program, and I want to show you how different plant material responds to different conditions, and then talk about some of the work that we're doing looking at specific clones and rootstocks. But first I want to just explain quickly about cold hardiness and what is cold hardiness. But it's really the ability of a plant tissue to survive freezing temperature stresses. It's a complex trait, and it's controlled by both the genetic potential, the genetic of the plant, but also the environment. So the genetic potential is limited by its genetics. So a variety like Frontenac or Riparia Gloire, if you look at a rootstock like Riparia Gloire, they have a lot of Vitis riparia in their background, or they're pure Vitis riparia, and so they have a lot more cold tolerance than a variety like Pinot Noir, which is a vinifera. The other point to make here is that it's a highly dynamic condition, and it changes throughout dormancy. And it goes through a period of acclimation, maximum hardiness, and then deacclimation. And depending on where the varieties or the grapevines are grown, it can have an impact in terms of how well they acclimate, how deep they go into their maximum hardiness, and so on. Each cultivar will have a difference in terms of cold tolerance. We have the main extremes, if you want to look at it here, would be your native North American species, Labruscas and Riparia would be your most extreme in terms of maximum cold tolerance, and Vitis vinifera would be the least tolerant. And here's just an example of different cultivars. This is from the Vine Alert program that we run at Brock. And what's nice about this program is that we have multiple years of data, a large database, so we're able to see how different varieties perform within a given season, but also from year to year. And within all those different years, a lot of times we have different extreme events. So we can really start to get a sense of what is happening and how these varieties perform based on climate. So if you can see here, these varieties have different rates of acclimation. Variety like Merlot, for example, is quite a few degrees less cold tolerant than a variety like Chardonnay, and they will deacclimate at different rates. Now, even within a season, even one cultivar over multiple seasons will respond differently. So this makes it very difficult to predict exactly how cold tolerant a plant will be at any given time, because some factors include growing season impacts, yield impacts, temperatures before a freeze event, and so on and so forth can all impact how, or warming during the season also can impact how cold tolerant these will be at a given time. So you can see here that in this particular year, 2017-18 actually, we had less, the vines acclimated at a slower rate, didn't reach as deep in terms of dormancy, and I don't have the final part of that graph, sorry. They also, they can also really differ in terms of rates of deacclimation. And this has a lot to do with temperatures that we experience during the winter months and during late winter and early spring. And in years where we have very warm conditions, the vines can deacclimate quite quickly. But different varieties and different species will have different rates of acclimation and deacclimation. And this is where variability and volatility in seasons can really have an impact. And this is where climate change can be of great danger for a lot of grape production, particularly in cold climate regions, where we have some warming during winter periods, the vines in that erratic condition where we have some really warm weather followed by extreme cold. And we can have devastating consequences because of that. Sometimes it could be bud damage, but it could also include killing entire vines because the sap is flowing in within the tissue and the trunks, and they end up splitting, and it can be really, really devastating when we have those really cold freezes late in the winter. And I'll talk about some varieties that are more susceptible with that, even though they're really, really cold tolerant. And here's just an example. It was basically the same chart as I showed before, but I took off a whole bunch of different varieties and wanted to show what a really cold winter, what the cold hardness dynamics of Chardonnay looks like in a really cold winter, where we have the vines acclimate at a higher rate, reaching a deeper level of maximum hardiness, and they'll stay dormant longer. Whereas in a year like 2011-12, you'll see in this gray line, the Chardonnay deacclimated at a very, very rapid rate. So at that given time, there could be like 15 degrees difference in cold tolerance in 1 year. Now this is where different plant material can have much different responses, and cold hardy hybrids are really, really good in a cold area where it stays cold. Like I said, Frontenac and Marquette, they have a lot of Phytis riparia in their background, and they reach much deeper levels of cold tolerance in midwinter, going down below -35 even in some years. Whereas Chardonnay, or in this case Riesling, you're looking at maximum hardness maybe around -25. Well, you can see that because of their genetics, they will deacclimate at an earlier rate. And at some points in time, these varieties will actually be less cold tolerant than even vinifera. And research has shown this with Labrusca varieties back in the 80s. Back in the 80s, there was some work done that looked at Concord and so on, and showed similar results. Now, in a warm year, this was 2015, 2016. We had a mild winter. We had very few critical temperature events for us in Ontario, so our growers weren't running wind machines very often in this particular year. And you can see that these riparia-based cold hardy varieties did not get as cold tolerant as they would in a really cold winter. Whereas the vinifera, where they evolved, they have warmer winters, and they basically got down to the same level of hardiness. So it's really, really interesting when you have a warm winter, some of these varieties are not bulletproof. and especially during the late winter periods, where they are much more susceptible to freeze injury than than even the vinifera varieties. So breeders, growers, we're all looking at this in terms of the response, and we have to be careful. Like, what do we need wind machines for some of these really hardy varieties? Because they're really good when it's really cold, like right now, this time of year, but what's going to happen this spring once we get some warm weather? And so this is just an example of 3 different seasons and how the difference a year can make with some of these varieties. Very, very cold year, and these get really, really cold tolerant. And other years where it's not as mild, this type of plant material will not be as cold tolerant and can be just as susceptible to freeze injury as what we would consider more tender vinifera. And this is a result. In some years, in some of these varieties, we have seen, in other regions across North America, have seen the frost damage, post-bud break, trunk damage, and it's a real concern, especially in areas of the Midwest where they can have those real continental climates, where they have that continental climate. So one of the big things that we've been working on, we started working on a number of years, I think 2 years ago now, was the evaluation of different plant material in a formal manner, not just looking at cold tolerance, but looking at overall performance for different clone and rootstocks. And part of this is the need to complement the Clean Plant Program, the Canadian Grapevine Certification Network. And so we're evaluating material to feed into this program. And we looked at establishing a research program to evaluate different clones and rootstocks in formal experimental blocks, taking that vine to glass approach, so looking at cold hardness dynamics all the way to disease resistance and fruit quality. And it's basically looking at a long-term solution to mitigate some of the climate change impacts, as well as to build a quality and consistent industry. So in recent years, just last year really, we finally planted a cultivar clone rootstock evaluation block, and this is working with Debbie Ingalls and Belinda Kemp. So we have myself on the viticulture side, a biochemist and an enologist working together for this multidisciplinary project. We're working with the industry specifically at their own research vineyards. So we have 2 different plots on different soils, and on each one of these different plots, we have a combination of different varieties, clones, and rootstocks of our major, some of our major core varieties that we're growing in Ontario. What I'm going to show you is some data that preluded the planting of this vineyard, and looking at some clone and rootstock impacts in commercial vineyards with mature vines. And these blocks were established by industry, some pioneers in industry, to look at different clones and rootstocks, and they actually set them up so that we could do this type of work. Not when they planted them, it was for their own purpose, but because they were in the ground, we were able to capitalize on what they had in the ground. So I want to show you some data on 4 different Sauvignon Blanc clones, on 1 rootstock, SO4, and then a couple different Riesling clones on some different rootstock, as well as 12 different Chardonnay, all planted on the same rootstock in the same block. So this is the very first slide I want to show you, and I've taken off the individual clones because I'm waiting until we get more data before we present this to the entire industry, but this is really broadcast wide. So we're keeping this close right now, but what I want, the take-home message here is there's 12 different Chardonnay here, all from the same location, and some key things to point out is that there's certain clones that have different acclimation rates compared to others. Some clones really differ in terms of how they, the second stage here, acclimation, there's some differences here with specific clones. Maximum hardiness can vary. And what's interesting here is that we haven't found a lot of difference during deacclimation. for a lot of these Chardonnay clones. It seems that once it warms up, they deacclimate at similar rates. But in some years, we do find a little bit of variation. So it's pretty interesting, and we've had consistent results here for a number of years with these different Chardonnay clones. This is a slide from our PhD student, Andrian Haber-Haché, and this is just, again, showing you how different varieties can differ in terms of their hardiness. So on the top here is Sauvignon Blanc, and the bottom here is Riesling, and each one of these different colors are different clones of each. So you can see that certain clones of Sauvignon Blanc are less hardy than others, and the same thing with Riesling. And we're seeing pretty consistent results from year to year, and it seems like most of the differences are during maximum hardiness, which is really interesting. And you can see here again, when we're sampling every 2 weeks, it's not static. When the temperatures warm up, we're seeing a little bit of a decline in hardiness or a decrease in hardiness. And it's not a perfectly smooth line like some of those cartoons I showed you at the beginning. This is the reality of how hardiness hardiness works in plants. And what's another interesting thing here is Riesling is generally more cold tolerant, but in some years they can actually be a little bit less cold tolerant during deacclimation, getting closer to bud break. Here's another example of 3 different years. So I showed you in 1 year how the differences can be. And here I want to just show you, thank you to Andrian for the slide, is looking at 3 different years with Sauvignon Blanc and how, I'll show just pinpoint a couple clones here. This clone here, which is the yellow line, is fairly consistent in terms of being slightly more cold tolerant than all the rest. Now, one thing I always talk to my students about is sometimes we don't have the statistical significance on this chart, but sometimes we'll have periods of time with little differences in hardiness, but they're statistically significant, and other times they're not statistically significant, but there's huge gaps, and it's like, well, that's the difference in the relevance of biological significance and statistical significance. Sometimes it might not be statistically significant, but in reality to a grower it could be a big deal. And a couple degrees of hardiness can make a big difference where we are growing grapes, at least, where we're just on the threshold many times of having either 10% damage or 50% damage or more. Now, looking at different clones on one rootstock, these 2 Riesling clones are slightly different in hardiness throughout all of, throughout all of dormancy. And again, they're changing to periods of different temperature changes or climatic changes, but basically the relative difference remains roughly the same between these 2 clones. This is on Riparia Gloire rootstock. And we're starting to see some similar trends in 2018-19 there as well. It's right down here. Now looking at rootstock, this is the same clone 49, on different rootstocks. And you can see that even with just rootstock alone, there could be some differences in hardiness throughout dormancy. And we're looking at things like yields and vigor and crop levels and loads and so on to see if the rootstocks are having an indirect effect. But in many cases, it really seems like the rootstock can, just the rootstock alone can have some slight improvements in tolerance. Now here in Ontario, we use very adaptable rootstocks. So we're looking at, this is one reason why we're looking at hardiness. Other regions, they're really focused on, in warm, dry regions, their main focus with rootstock selection is drought tolerance, for example, or other types of salinity resistance and so on and so forth. But here we're interested in those things, but it's really interesting to look at the hardiness aspects. And just to show you a similar thing with a different clone, we can have slightly different responses with that true clone, that variety clone rootstock effect. Oops. And you can see that in some cases, we can even get some difference in how the rootstocks perform, let's say during acclimation. This was a really wet year, and in the fall, And we see that this year we have some slight differences with the rootstock, and it's likely due to the really wet growing season that we had. We get slightly different performance of the rootstock at this particular period of time. But we'll see if that holds true in other years. This is why this is long-term research, looking at plant material. It's a long process. So other research that we're doing, I showed you some data on the hardiness of different varieties. We're continuing to do that. We have like 9 years of data on many varieties, and we're going to continue to do that to look at how these varieties perform long-term and understand how the environment really impacts these. Our goal is ultimately to look at improving modeling, cold hardiness models and grading, and also use those to help us mitigate freeze injury in the short term, but also long-term impacts of how these varieties might perform in years to come. The other thing we're looking at is I just touched on clone and rootstock and specifically hardiness, but we're looking at many different aspects of clone and rootstock combinations, including overall performance, fruit quality, and wine quality potential. So we're making wines from these different combinations as well. And then also looking at, down the road, future evaluations and potential selections within our own vineyards for greater resistance up to freeze injury within some of our core varieties. So when we have periods of cold weather, is actually flagging these vines, seeing if they perform consistently from year to year, that they're clean of major viruses and so on and so forth, and not only evaluate them here in Ontario, but propagate those vines and plant them out in BC, Nova Scotia, and so on, see if they have common, if it's a common trait across all regions, or is it something just specific to that vine growing in Ontario, for example. So with that, this is some of the exciting work that we're going to be doing through the new AAFC cluster activity for the Canadian Grapevine Certification Network. So the specific activity that I'm involved with is the Grapevine Evaluation and Cold Hardiness Program. And we're looking at some key objectives. One is to evaluate grapevine material performance, cold tolerance, and quality, and the other is to assist with selection of superior plant material. So we're working with colleagues all across Canada on this activity and linked with other activities to really help push Canada ahead in terms of dealing with climate change and having a clean plant program through the CGCN, which is the Canadian Grapevine Certification Network. So we're really excited about this opportunity. But just to conclude, with the general warming, it's still going to be a threat in cool climate regions for freeze injury. And this is, again, why we're still focusing on cold hardiness. And if you look at the 2019 priorities for our industry, freeze mitigation is still on as one of the top priorities. Plant material will be likely the most cost-effective long-term mitigation strategy to deal with climate change. One of the biggest challenges, and it's a continuous challenge, is we can have these great varieties or selections, but it comes down to market demands, what the market wants as well, and as well as regulations. And when you look at not only Ontario and VQA and what have you, but you look at the AOC and other appellation systems worldwide, it's like I said, it's an integrated strategy that needs to take place because there's a lot of policy involved as well as the market and what people want. So that's just, again, why we're looking a lot on the clone and rootstock right now here in Ontario. There's a lot of efforts worldwide, but it's really truly a global effort for selection, evaluation, and material. There's a lot of really cool material coming out worldwide, and it would be great if that material could be evaluated all over the world as well, not just where it's being sourced from. And there's actually going to be a lecture next month from a professor from Italy talking about disease-resistant Italian varieties. So the Italians are doing this work, the French, everybody, the Americans. It's really important, and like I said, it's a global effort to tackle this. So moving forward, like I said, the Canadian grape and wine industry will benefit tremendously, I think, through this coordinated effort. This first time we've had a grape cluster research activity with Agriculture Agri-Food Canada. Ultimately, and this is not only just through better evaluation programs, but through the Clean Plant Program, better plant material will lead to optimum health, improved winter survival, and lead to a more sustainable and quality industry. And when we're better adapted to deal with climate change, there's a lot of unknowns and extremes in climate that will present great challenges. And this is one of the things that, you know, concerns I think all of us the most is what are these unknowns? How the scientists that are involved with climate change, and when you look at the studies out there from, you know, and publications from thousands of scientists, and they're pleading government officials to act, it's because they're concerned that if it reaches a certain tipping point, there's not going to be anything we can do. And it's better to be prepared than to face the ultimate suffering, really, from not doing anything. But the real solution is an integrated climate change mitigation strategy, and that's what's really necessary. If scientists are doing work looking at various programs, but there's no policy, there's no funding, there's no support, there's no initiatives for industry to buy in, then it's all going to fail. And this has been one of the biggest problems, whether it's the Paris Accord or anything locally. It's a challenge. So it's probably the bigger challenge than looking at plant material for vines. It's really the entire strategy. So with that, I want to thank everyone here at CCOVI who I work with and who has helped provide some data for this presentation, as well as all of our funders, funding agencies, our industry partners, growers and winery cooperators that help us with all of our data collection. So I hope I told a little bit of a story here, and I'm happy to take some questions.
The disease-resistant varieties over in Europe, there's so many of them, and each of the European countries have their own breeding program, which Andy's going to talk about in Nigel. But how much do we know about the cold tolerance of them? This is now 3 parts, as I've just wondered. And do you have any plans to work on any of those with regards to cold tolerance or bring any over here?
Okay, the first question was, there's a lot of different selection programs and breeding programs worldwide, particularly in Europe, that are working with new disease-resistant varieties. And the first part of the question was, do I know if they've done cold hardness work, or if there's any cold hardness differences with these varieties? I don't know. Okay. In a place like Italy, I'm not really sure if that's a main trait that they'd be looking at. They're looking strictly at, you know, powdered mildew resistance and so on and so forth. I would love to evaluate as much material as possible, but this is all in consultation with the industry. But I do think that there's great opportunity to look at some of these varieties, because we have disease issues big time here in Canada, as you know.
And lots of places like Denmark and Sweden and Switzerland, that's just what I wanted.
Yeah, and I think that's where that global networking is really important, because these varieties might perform even better in Canada than, you know, other cool climate regions. You don't know until you try them. So I think you always have to, you have to focus, but there's potentially some varieties to look at here. So a lot of them are new and they're just getting into the program, but this is where, if Canada has a domestic clean plant program, that's where those varieties should go, and they can start there. Like Foundation Plant Services in the U.S. are getting some of these varieties in, from what I understand.
Debbie and I would like to know if you could name each one of the 14,000 grape cultivars.
My goal is to taste everyone. No. Every day, you hear different varieties, and it's fascinating. I think it's one of the coolest things, and where they originate from. They have, different characteristics, but no. A lot of them are probably the same variety once they start looking at the genetics of them.
Do we have any other questions from the audience for Jim?
My goodness. Jim, thank you very much on behalf of COVI for stellar lecture today. Just a couple of additional announcements. Linking into what you were saying in the questions, Belinda, you were asking, we do have a guest speaker, Dr. Enrico Peterlunger from the University of Udine in Italy, coming here Friday, February 22nd. It's a special lecture, and he'll be doing a wine tasting of new grape cultivars with disease resistance and increased sustainability. So Dr. Peterlunger will be presenting that work at the Ontario Fruit and Veggie Convention, his research, but here will be the opportunity for a tasting of the wines from that research program. So special date and time, Friday, February 22nd, 2 to 4, here in this lecture room. And the other promotion I wanted to acknowledge, Dr. Andy Reynolds is going to be talking next week here on material other than grapes. So in the impact that this material, especially if the vines have gone through freeze prior to harvesting the fruit, what impact that material may have on the wines if it gets mixed in with the fruit upon harvest. And taking a look at some of the aromatic qualities of those wines and some of the unwanted floral attributes that can result. So hope to see everybody here next week for that exciting lecture, and have a great day. Thank you.